Now I'm going to go down to lectures, and we will very quickly review some basic concepts that deal with GIS, and that will maybe reinforce some of the things that you learn in the lesson and in the lab. Okay, so GIS stands for Geographic Information Systems. You'll hear lots of different terms that people throw out there and different definitions, but for this class I want you to remember that it is Geographic Information Systems. And because it is a system, this is a combination of many different things. It is not just a piece of software. It's the computer you're using, the data you're using, the products you produce, and so on. So it's not just a piece of software or Esri or ArcMap as many people often refer to. Remember, it is a geographic information system, which is a combination of maybe maps. It could be three-dimensional. It could have pictures or other media content that is included. There's also tabular information. So here we can see that there's some information relating to fire hydrants, where people have gone out and collected GPS data and then tabularly recorded information about the geographic objects they're collecting in the field, and then they're able to put that stuff on a map and present it in a very new, unique way. Okay, so what makes a GIS different from, let's take for instance Google Earth? Well, there are several different things, and so the main thing that makes a GIS different from Google Earth is that a GIS allows you to use tools to solve problems, to model data, to symbolize geographic phenomenon, to visualize things that are going on the surface of the Earth, and to manipulate that data. So Google Earth is very nice for displaying geographic information and for visualizing it, but you don't have the same abilities to analyze the data and to manipulate the data that you might be able to do in a different type of GIS platform. So I want you to really keep in mind that a lot of mapping applications or things that you see on the web are not what we would typically consider to be a GIS, but they are like a GIS. As I mentioned before, GIS stands for Geographic Information Systems. And what makes a GIS really unique is that it links databases to maps. So we are able to take information that is commonly stored in a database or a table, and we're able to display that spatially. And that's where the real power lies. Helps us manage information about places, and it helps us answer questions. For example, we might want to know where something is, or what's nearby, or where the highest concentration of a pollutant is. We might want to know the distance between two related objects, or where a chemical plume is supposed to disperse. So what it really allows us to do is to analyze data, but it allows us to analyze it using the spatial component, and that's where the real power lies. When we talk about the different components of a GIS, historically it has been broken down into 5 different sections. However, as the software has evolved, some people have kind of merged GIS into 4 categories, but I still like the traditional definition. So for the purpose of this class, we will say that a GIS links spatial and tabular data together and enables people to visualize spatial patterns, relationships, and trends. And what this does is it gives a totally new perspective on data analysis that cannot be seen in a table or in some other sort of list format. So essentially what the GIS allows you to do is to spatially enable data. And it's made up of software. The software you use in this class will be ArcGIS 10. There's also the data component, so you may be collecting data on a GPS. All of this has to be done on a computer, which we refer to as hardware. And then there's also people who have to manipulate and use the GIS. And then there are methods, which we may refer to as tools or different analysis techniques that we use within GIS. So what I really want you guys to remember is that a GIS is a system made up of many different components, and it is not just a piece of software. Now, what makes a GIS different from a map? Well, the GIS allows us to overlay data. And we can overlay data that maybe comes from many different sources. And we use these overlays to model the real world. So here we can see we have one layer, which is maybe a transportation map, which has roads or railroads, bike paths, sidewalks, things of that nature. The next layer might deal with gas. The next one might be water and sewer. Then we could have telecommunications, electricity, vegetation type, hydrology, and then maybe some sort of subsurface layer which deals with soil. And what we can do is we can overlay all of these on top of each other to more accurately depict and model the real world. This is not something that you could do with the traditional map, because when you put one map on top of the other, you can't see what's underneath. With the GIS, you can. You can turn different layers on and off. You can organize them in different ways, and this gives us a lot more analysis power. Now, things get a little bit more complicated than just talking about a layer. And remember, a layer might be a road layer, an electric layer, a water layer, or something that is representing geographic phenomenon. So one, we get the graphical display, but two, there is a tabular display. So we have a spatial and a tabular component. Here we can see this is the spatial component, maybe the traditional map, but it is linked to a table. So here we have some wells where we're monitoring for concentration of a contaminant. Each spot on the map is linked to a row in the table. So we could maybe say that this well right here has a concentration of 300 for that particular contaminant. Now down here we might have a layer representing different types of industries, right? And maybe this is a metal foundry, and over here this is a fertilizer plant, and over here this is a poultry packing plant. We have information that gives us the address, the type of facility, maybe what they produce. And when we overlay these two things together, we can begin to draw some comparisons between the type of contaminants and what that industry is. And then we could go one step further, and we could maybe look at how heavily populated an area is. So here we can look at this layer, and we can say, okay, in this section of the map, there are 6 people that live there. In the other section, there's only 2. So again, what makes the GIS really powerful is that we're using spatial and tabular information to model and analyze the real world. Now, when we talk about the different types of GIS data, there are 2 very distinct categories. We have vector information, or vector layers, and we also have raster information, or raster layers. So remember, when we're talking about different types of data or different maps within the GIS, we refer to them as layers. In this picture, we have 4 layers. We have a customers layer, a streets layer, a parcels layer. We actually have 5, an elevation layer, and a land use layer. All of these are used to, again, model the real world. Now, there's some important distinctions between vector type information and raster type information. Vector data is synonymous with maybe points, lines, and polygons. So when you think vector, I want you to think back to basic geometry. We're modeling the real world using points, lines, and polygons. So a point location of a customer or a GPS would be vector because it's a point. The point is representing a geographic object in the real world. Streets are lines, right? And you kind of need to think about how things look in the real world. A road on most maps, and when you look at it, represents a linear feature, so we use a line to represent that, and the line is a vector type of data. Parcels refer to a piece of land or a lot that a person owns. Lots are polygons, right, where you have different sides. It's enclosed, you have boundaries. So again, this is a vector type, but it is a polygon type of data. So most of the time, we say that vector data is used to represent discrete objects in the real world, whereas raster data is used to represent continuous objects in the real world. So an example of a continuous phenomenon would be something like elevation, where there's a value that can be measured everywhere on the Earth. Other types of continuous phenomenon might be temperature, or wind, or precipitation, or barometric pressure, right? So the thing that we're representing exists everywhere on the surface of the Earth. The difference between rasters and vectors is that rasters are made up of cells, and a collection of cells is something we refer to as a grid. So if you look down in this picture, you could say that this whole area is one grid, and it's made up of a bunch of little tiny cells, which are squares. So I want you to think that rasters are synonymous with pictures, right? And a pixel is basically the same thing as a cell. So everyone knows what a megapixel is on a digital camera. All right, if you zoom in real close, you can see the little tiny squares that make up the picture. The raster is the exact same thing. So a satellite image or an aerial photograph that you see in Google Earth is a good example of a raster type of data. Remember, vector is geometry, point signs and polygons. Raster is picture, pixels and cells. The last thing that I want to talk about today is that GIS is really expanding very rapidly. If you look at some of the more recent job reports that have been published from the U.S. government, it's one of the fastest growing industries and is expected to continue growing for the next 30 years. And if we look at many of the different universities throughout the world, we can see that GIS is being taught in a variety of different disciplines. It's being used in agriculture and archaeology and business. There's now a fusion between computer scientists and geographers who use GIS. It's really all over the place. You see maps on the Weather Channel where meteorologists are predicting, how severe a snowstorm or a rain event is going to be. Oceanographers are using it. It's used in law enforcement and public health now. There's virtually GIS being used almost in every discipline that we see out there today. Just to talk about a couple of these examples, if we move into agriculture, we can see that people are using it to manage farms. Maybe they're kind of planning what crops to plant or how they're going to rotate crops. They're using GIS to track disease and pest. Some of you guys might have actually seen the purple boxes that are out hanging near interstates, and these are actually bug traps for, I think it's it might be the gypsy moth or one of these invasive species that's destroying some of the forests on the East Coast. And what some scientists have done is they've GPSed or tagged the location of those traps, and then they go out and count the number of bugs that have been caught in them, and then they create maps showing the density and the dispersion of these bugs. You can also use GIS to do yield prediction and to kind of think about where the best places are to plant certain types of crops. So if you look down in this graphic down here, we can see that there's areas in green and there's also areas in red. And what this is it's a viticulture suitability map where people looked at the different types of soil, the aspect, and the elevation of the land and tried to predict what areas would be best to grow grapes. And so all the areas that are green are considered to be good for growing grapes. Other examples in using GIS for natural resources deal with forestry. So maybe people are planning how to harvest timber, and so they've mapped out different types of forest stands, and maybe they map when they cut them and possibly even predict how much timber they expect to get out of them. Ecologists are using GIS to track invasive species or the reintroduction of species. In Virginia, there's actually a new project where elk were reintroduced, and the elks all have GPS collars so that people can monitor their movement and dispersion on a map. And let's see, also in mining and other sorts of natural resources extraction, GIS is very important. It's been used for a long time in the petroleum industry to try and identify places to drill to extract oil or natural gas. We actually have several students now who work in the natural gas industry where they do permitting maps for fracking companies. Another big area where GIS is used is in local government, where planners or economic development officials generate land use or zoning maps. They do lots of emergency preparedness, where they might develop evacuation routes or kind of predict what areas might be flooded. There's population forecast marketing analysis. If anyone's ever bought a home, there's many different types of GIS applications that show property information, lots, home prices, and you could even look at things like demographic information, so the age of people in a certain area, how much money they make. The list goes on and on. And of course, one of the areas where most people are probably familiar with GIS or geospatial technology is transportation. We're all probably familiar with MapQuest or Google Maps, where we can get directions, or we have our GPS in our car that gives us turn-by-turn directions. Sometimes we probably get lost, but these things have kind of become intertwined in our daily lives, and many times we don't realize how they're produced or how they work. So one of the things we're going to do in this class is really look at how people make these things. So at the end of the day, what I want you to think about that is that a GIS is really a framework that you can use to understand and manage the Earth. So what we do is we use a GIS to kind of to systematically analyze things that are going on in the world, and then we can visualize them in new and innovative ways. So that's all that I really want to cover today. I will continue to post more online lectures and content for you guys. Please email me if you have any questions. I'd be glad to offer them, and we will continue moving on. Thanks.